Hi class, so welcome to the last video for EDA. Alright, so for this lesson or for this video, this will be the pinnacle of your um, engineering statistics. So here we're going to apply statistics to a very particular kind of experiment. So there are many kinds of approach in doing experiment. You can either go em empirical empirical models. So when we say empirical models is that we measure and we test. Okay, so for example, empirical experiments is we simply empirical. So we simply do measurements, right? So empirical, that by definition is based on, concerned with, or verifiable by observation or experience rather than theory or pure logic. So again, there are two approaches in basically doing anything. So you can do an empirical. So with empirical, you measure and then you create a model. So and the other one is purely statistical. Okay, so we use um, statistical approach. So you are collecting so many data, and you're going to create a model, and then you can use that model to predict. You can use the model to predict several kinds of outcomes. So basically, empirical models will give you the so in a nutshell, empirical model can give you the explanation about a phenomena, while a statistical approach can give you the model of the phenomena as well as the prediction of other possibilities in the phenomena. So that's statistical. So we're going to combine empirical and statistical analysis today. So so as you can see, this is Faraday's electromagnetic lab, courtesy by FET Colorado simulation. So para dun sa mga engineering mechanics ko, so we're going to use heavily PET. We're going to heavily use PET beginning next week on cluster 3. So so tatry natin gamitan to ng statistics. But before that, let's discuss or have an overview first about design of experiment. So what are design of experiment in the sense of engineering design, right? So DOE has an objective to understand the foundation of methodology itself. And for this topic, we're going to interpret and apply basic stat tools, so related to DOE. So yung mga naunang topics is more on F value, P value, T, paired T-test, Z-test, so Z-scores, T-scores, so ANOVA. So actually in DOE, gumagamit siya ng ANOVA. So I guess makaka-relate kayo. So number 3, objective for this topic is for you to know how to plan, conduct, and analyze, as well as to implement the fundamental and practical industrial experiments. For example, if you're going to develop a certain kind of material, so you can use DOE. And lastly is this topic or this slide will teach you how to understand the application of Minitab. So maraming klase na statistical analysis software na ginagamit. But for this lesson, we're going to try how to use the Minitab. Okay? So, kung di man Minitab, we'll try to use Excel. So, in this topic, I'm going to expect that you understand. So, at the end of this topic, you should understand how design of experiments can greatly improve product quality. Second one is after the end of this topic, you should be able to apply full cycle of the DOE process. So here you will have an idea how to plan, how to conduct, and how to analyze, and lastly how to implement your experiment. And number 3, hindi naman necessary or hindi naman important is to know how to use the Minitab software. So this is the Minitab software. Actually, di siya free. But if you manage to get something version that is free, then good for you. Okay. So we used Minitab in doing experiments because what's the difference between Excel and Minitab is that Minitab is more specifically created for statistics, while ang Excel kasi is a jack of all trades. Okay? So yun ang difference ng Minitab at ng Excel. So first one, topic is to strategize how to do experimentation. And then number 2 is the typical application of experimental design. So how do we do it? Number 3 is basic principles. Number 4 is guidelines for designing. So there are guidelines. And that's part 1. And for part 2, okay? So I tingin ko hindi natin naabutin to. Sa introduction lang tayo, outline. And then we're going to do basic application. Okay? So an experiment is a test or series of tests. So that's an experiment. So the design of an experiment plays a major role in eventual solution of the problem. Because again, how are you going to do your experiment will greatly affect the outcomes. Okay? So kung badly designed ng iyong experiment, of course, you will not get a good result. Also, in a factorial experimental design, experimental trials or runs are performed at all combinations of factor levels. Mamaya, explain ko sa inyo kung ano ibig sabihin nito. So lastly, analysis of variance. Yun nga, we use analysis of variance primarily in determining, basically, we use ANOVA in design of experiments. So this is the primary tool that we use. So, okay, so engineering experiments here, you can see inputs. So you have inputs. You also have controllable factors, may explain ko sa inyo. And then we also have uncontrollable factors because this is really our undesirables. So in order for us to overcome or to reduce the uncontrollable factors, we isolate the process itself. So what I mean to say is that you will control the experiment to reduce the uncontrollable factors. And lastly, if you have inputs, the output is called a response. So this is not a result, but it is called a response. So whenever you have an input and then you control the factors of an input, results to a different kind of response. So mamaya, kita nyo. So factors are controllable experimental values or variables that can influence the observed values. So Tagalog, ito yung mga kaya natin i-control. So we can measure, we can control their severity or their magnitude in a way that whenever that we change the value of the controllable factors, nagre-respond, meron tayong ine-expect na response. Okay, so the response variable is any outcome or result of an experiment. Okay, so take note, any outcome. So this is not outcomes and this is not results, but you're only expecting one outcome. Right? So you have many inputs. You have inputs, kaya may S, and you only have one outcome or result or response. Right? So if you have many response to expect, it's very difficult for you to, to do experiment because it's like you are asking too many questions. So one question at a time lang. So for objectives of the engineering experiments is that why do we use DOE? Okay, so let me give you an example. So if you don't know how to use DOE, you will do experiments in the way that you want it. Alright, so experience ko kasi nung high school and then college, gumagawa lang ako ng pauno-uno experiment without knowing that there is the right way how to do experiments. So kung alam ko lang siguro na mayroong design of experiments noon is mas madali paggawa ng analysis. Okay? Again, we use DOE in product designs. So, I guess, nasabi ko na sa inyo before na ang madalas na gumamit ng mga DOE ay yung mga industrial engineers because they create products. They create products na magsusuit for a wide range of users. For example, gagawa tayo ng upuan, okay? Example, chair. So if you're going to consider this kind of chair, so marami na agad tayong iniisip na factor. Ano yung size, 'di ba? Kikita niyo naman, 'di ba? Maraming klase ng chair. And chairs at nagbabago-bago yung ay magkakaiba yung mga design at saka itsura, haba ng paa, yung lapad ng likod, depende sa mga user. Alright? So, if one of the scopes of industrial engineers is yung tinatawag na ergonomics. So, sa ergonomics, basically, it says, kapag hindi maganda yung ergonomics ng isang product, prone to defect or prone sa sakit ng katawan ng tao. For example, kapag sobrang taas ng chair mo, hindi siya ergonomically balanced sa table mo, sasakit yung kamay mo o sasakit yung leeg mo kapag nagtatrabaho ka. So, industrial engineers design products na ergonomically designed para hindi sumakit yung leeg mo o hindi sumakit yung likod mo. So, they use statistics for that one. So, they use DOE. One of their use, I mean, hindi naman yun ang ginagamit nila. Isa lang yun sa ginagamit nila. But the point is, we use DOE in uh, in reducing time to design, develop new products. Kasi hindi to tinatawag na pachamba-chamba. So, hindi pachamba-chamba ang approach sa DOE. Hindi siya yung tipong taon-unong experiment yang buo ka to. Sa DOE, imo talaga i-design katong imong experiment para may expect mo kung ano yung mga outcome. Hindi yung, ganito pala yung mangyayari. Hindi ko in-expect na ganito mangyayari. So, ganon. So, yun ang DOE. The second reason is we use DOE to improve performance of existing processes. Again, it doesn't really mean that something works cannot be improved. So, pwede pa natin improve yung mga bagay-bagay. Pero, syempre, may mga limitation tayo because, again, hindi lahat ng bagay kailangang improve. Okay? For example, gulong. Isipin nyo pa paano natin i-improve yung gulong. I don't know. Maybe, I don't know, paano ba i-improve yung gulong? I mean, kailangan pa ba i-improve yung gulong? Diba? Parang ganun question. So, gusto nyo bang gawing triangle ng gulong? I mean, the most optimal shape is probably the honeycomb shape. Pero, hindi rin siya magandang gawing gulong. But I don't know. Maybe you know. Okay, so the third reason is that we improve reliability and performance of products. So, obviously, again, if you're going to improve something, we're going to improve one or many of its aspects. So, kasama yung reliability. So, fourth one is achieve product and process robustness. This is more on IE. I don't know about this one. So, and lastly is we use DOE to evaluate materials, design alternatives, setting components, system tolerance, etc. So, in a nutshell, when we try to develop a product, for example, you want to try to test a new kind of aggregate, so sa mga CE. So, kung gusto niyo mag-introduce ng bagong aggregate, so gagamitin niyo ng DOE yun. So, because you are evaluating materials and design alternatives. Okay, so I hope clear. So, the basic principles is one, of course, yung pinaka-importante sa stat, randomization. Okay, so we have to do it randomly. So, running trials in an experiment in random order. So, also, one of the important factors in stat is replication. So, sample size, improving precisions. Again, the more sample size that you have, the more robust your analysis. And blocking is more like coherence. Kung naalala nyo last time sa first topic, blocking is like coherence. Okay? So here, hindi ka gagamit ng, for example, if you're going to design a particular aggregate for a concrete or concrete hollow blocks, hindi ka gagamit ng aggregates from different sources. You will only use one particular aggregate from one particular place or location. So, hindi ka pwedeng gumamit ng magkakaiba. Kung gagamit ka man ng magkakaiba, i-blocking nyo yun or yun nga, yung coherence. So, kapag galing sa romblon yung aggregate, sa romblon lang. Kapag galing tablas, sa tablas lang. Okay? So, randomization, replication, and blocking. So, baka lumabas sa exam. Okay, so sa planning and conducting naman, mamaya na lang. Siguro, wait lang. So, recognition and statement of the problem. Okay, so, kaya ako pinagawa sa inyo yung case study nyo. So, why do you have to start with the problem? Because it is the most essential thing. And that's the first step you have to do. You have to define the problem. Okay? So, why do we use again DOE? Because we want to improve We want to improve products. We want to improve systems. So, hindi naman natin i-improve yung isang bagay kung wala tayong napansing problema, di ba? Hindi natin siya i-improve. For example, bakit ka bibili ng panibagong TV kung gumagana naman ang TV mo? Unless sira yung TV mo, kaya bibili ka ng bago. So, second one is choice of factors. Okay, so choice of factors, levels, and ranges, mamaya, pakita ko. So, the selection of the response variables, mamaya din. So, choice of design. So, I'm not quite sure about this one though. Conducting experiments. So, how are you going to conduct your experiments? So, ano ba? Maraming klase, no? You can do empirical, you can do numerical, or statistical. Okay, so statistical analysis, ang sagot dito, ANOVA na agad. We use ANOVA in DOE. So, drawing conclusions, core recommendations is that from the statistical analysis and from the findings that we obtain, we are going to create our conclusion based on the analysis and the facts. Okay, so factorial designs, many experiments involved, yeah, blah, blah, blah. Blah, 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 blah. Okay, so meron tayong two-factor factorial design. Ito yung pinakasimple. Okay, mamaya, pakita ko sa inyo. Two-factor. So, ibig sabihin, from the name itself, dalawang factor. Obvious naman. Okay, so wag na muna yan. So, dito tayo punta sa ano? Dito tayo pupunta sa yan, Faraday's electromag. Ito, medyo masaya to. Right. So, again, one of the basics of DOE is that we have to understand first our factors. Okay, so, mga kami ko, Paint 3D. Okay. So, dito sa experiment na ito, makikita nyo, okay, so, ito pala is the basic concept of generator. Okay, so kapag every time na merong magnet na nagsispin or changing magnetic field near a coil, mag-induce yun ng voltage. Okay, in a reason. So the faster the spinning of the magnet goes, okay, so ganun din yung nangyayari sa voltage. Right. So maraming approach or variations sa experiment na ito. So you can either increase the speed. Makikita nyo naman may RPM, di ba? Or you can change how big the coil is. Okay? You can change that. Okay, you can change that. Also, you can change the number of the loops. Okay? Pwede yan. So, maraming pwedeng baguhin. And also, you can change how strong the magnet is. You can change the strength of the magnet. So, pwedeng 0%. So, ibig sabihin, hindi siya magnet. 50% strength of a magnet or 100% strength of a magnet. So, marami tayong pwedeng gawin dito. Okay? So, but the point here is, ang ating response is the voltage. So, whenever we try to change several factors inside the simulation, ang ating response lang ay yung voltage or yung intensity ng ilaw. But since we cannot measure the intensity of light here, we can only rely on the meter of the voltage. Alright? So, again, every time that we change something in the variables, there will be changes in our voltage, which is the response. Ulitin ko lang ha, yung output is the response, and that response is the voltage. Right? So, basic is the part is that we have to understand first what are our factors. So, since this is a two-factor DOE, we only have to choose two factors to consider. So, I don't know, maybe we'll take a pick. So probably we can go for our RPM. Siguro RPM yung ating factor A. Okay, factor A natin is yung RPM or revolution per minute. Ang ating factor B is factor B natin is yung try natin yung loop area. Huwag na lang, yung number of coils na lang. So ibig sabihin, di ba nagbabago natin yung loop area at saka yung strength ng magnet? So, ibig sabihin, i-maximize natin yan. Ang babaguhin lang natin ay yung loops. Okay? Yung loops lang. So, ibig sabihin, ang ating factor B, pwede naman actually yung loop area. Pwede naman. Pero pwede rin naman ang loops. Pwede rin naman ang strength. Pero ang pipiliin ko lang yung loops. So, ibig sabihin, ang strength at ang loop area ay fixed. Constant lang sila. They will not change. So, ito yung tinatawag nating controllable. And then, ito yung tinatawag nating controllable values. Ito naman yung ating external. So, yung external natin, i-fix na natin sila para hindi na tayo, para walang nuisance. So, walang errors. So again, loops lang babaguhin. And B natin, factor is number of loops. Okay? So, ito yung ating levels. Now, we go to randomization. So, teka lang. By default, naka-random talaga dapat na experiment. So second one is replication. So the question is, how many times are we going to replicate? I don't know, maybe we do three replications? Ano ibig sabihin ng 3 replications, sir? So, ibig sabihin ng 3 replications is that we're going to measure them in random and in triplicates. So, tatlong beses. Okay? Tatlong beses. So, let's say, meron pa tayong kulang dito, yung levels. So, importante yung levels sa factorial design. So, sa levels, we can either go for our low, medium, and then high. Also, we can go, wait lang, try ko lang. Alright, so we can go to, again, low, mid, and then high. Also, sa loops, ganun din gagawin natin, tatlo din. So, low, mid, and then high. Now, we have to put values or designate values for each levels. So, I don't know, take your pick. Are we going to set a low which is 0? I don't know, hindi magandang idea yan. So, wag. So, looking back in our simulation, okay, pwede rin sabihin natin 20. Okay, 20. Sabihin natin na 20 RPM ang mababa natin. And let's say, ang ating medium is, I don't know, maybe 40. And then, ang ating high is 90. Ano? Ilang ang maximum nito? Natin ang maximum. 100. Okay. So, we can do mid natin is, let's say, 45. And then, atin ang high is 80. Alright? So, sa number of loops naman, wala naman tayong ibang choice kasi tatlo lang naman ang maximum natin. So, we can do 1, 2, 3. Okay. So, low natin is number 1, number 2, and number 3 loops. Right? So, all of these are in triplicates. Now, we're going to do combinations for each one. So, ito na yon. So, low combination to high, low combination to mid, low combination to low. We should also do mid to low combination, mid to mid combination, mid to high combination, and high to low combination. Wait, di makita. High to low combination, high to mid combination, and high to high combination. So, yun lang yung mga combination. Remember, we will do it in triplicates. So, ibig sabihin, low versus high is 3. So, ibig sabihin, tatlong nating beses gagawin yan low to high. Tatlong beses din natin gagawin ang low to mid. Tatlong beses din ang low to low. And so on and so forth. So, imagine if you're going to have 3 factors levels. So, 3, 6, 9. So, 9 times 369, 369. So 1, 2, 3, 4. So we have basically 4. Wait lang. 3, 6, 9, 1, 2, 3. So 9 times 3, we have 29 all in all. 27. 27 lahat ang ating data points or data sets. Data points, sorry. So 27 lahat ang ina-expect natin magiging ating value. So kung gagawa tayo ng table, 27 ang ating ina-expect. So how do we do this? Right, so kompleto na ba ang experiment natin? Yes, kompleto na. Pero may kulang na lang na isa. Ano yung ating response? O yung outcome or output? Ang ating response is voltage, of course. So, ano ba ang takbo nitong kwento? So, here we're going to determine what is the relationship between the RPN and a number of loops to the response, which is the voltage. So, here we're going to interpret everything about it. Okay? So, we try to use Minitab. So, data, stat, we use DOE, Factorial, create Factorial design. So, this is a two-level Factorial. So, number of factors, we have 2 factors. Okay, so designs. Okay, full Factorial design. Factors, we have A, numeric, yeah, numeric, yes. Low is not, no, later. Okay, factors. High, low, high. Dalawa lang. May ating factors, options. Okay, results. Okay, designs. Ang ating replicates is 3 replicates. We have number of blocks. We have 1 number of blocks. Okay, so since pares lang naman sila, number of center points per block. Okay, we have, okay. Factors. Factor A, B, C, D. Vertical. Okay, okay. Then, okay. Alright. So we have base design, we have 3 replicates, we have designs, 2 and 4 levels factors. So how to change the factors here? Wait lang. Define custom. We have 2 level lang, but 2 level. Pwede ba gawin 3 level to? Designs. I forgot. Yuri. Okay na natin, Google na natin. How to change number of factors in Minitab. DOE. Start, specify. Okay. So, factor. Forgot this one. Wait lang. No. General nga pala yun. I remember now. Start. General factorial design. Number of factors 2. Designs. Okay. Number of levels we have 3. Number of levels 3. Number of replicates we have 3. Okay, so replicates. Okay. Alright, so we have two factors. We have three replicates. We have three levels. So p-type 1, 2, p, 1, 2, 2. Okay. Alright. So this is 2 is to 2 is mid to mid. So mid to mid. Okay, so let's say natin ito na. Change na lang natin. So let's say that this low is 1 and mid is 2. 3 is high. 3. 1, 2, 3. Okay? So 2, 2, 1, 1. So ibig sabihin, ang 2 is mid is to mid, and this is low is to mid. This is high is to low. Right? So A natin. Okay? Alright. So balik tayo sa experiment natin. So first one is that we are also find mid to mid. Okay? So mid natin is 45, diba, sa RPM. So we get 45 RPM. Oops, sobra. Yan, 45 RPM. Ang ating loops ay 2. Tama ba? 2 is to 2? Alright, 2 is to 2. So, if we're going to interpolate is that we can observe 1, 2, 3, 4, 5, 6, 7. So, we get 7. Okay, so what I did is I changed the letter for this one. B kanina bakante yan. So I put B here. So to signify that the response is volts. So when we say mid, okay, so 2 or 2. Alright, sa ating experiment, that is, tabi ko lang ito. Ba't kasi hindi ko ito maigip na? Makasar naman ito. Isa-isayin ko talaga. So 2 is 7. Okay, so 1, 2. So RPM is low. Ang low natin is 20. Okay. So 20 ang ating loop is mid. So number 2. So ating volts is ito. So dito siya. 1, 2, 3, 4. So 4. So we put 4. So sa high na RPM, so RPM natin is at 80. Okay, 80 lang pre, hindi 100. Relax ka lang. So 80 RPM, ang ating loop is 1. So voltage natin is here na. It's around here. Okay, 1, 2, 3, 4, 5, 6, 7. 7 din. 1, 2, 3, 4, 5, 6. Bakit 6 lang, no? 1, 2, 3, 4, 5, 6. 6. 7. 6 siya. So, 3 is 3. So, ibig sabihin, maximum lahat. Okay. Okay. Maximum lahat. So, 80 and then maximum loops. So, ating voltage ay dito, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17. So, 17. Siyempre, 17 din. Ating low, ang RPM natin is low and then mid. Okay. Low ang RPM. Mid natin is 2. So, we have registered. Okay, 1, 2, 1, 2, 3, 4. So, registered 4. Okay. 4. Ang ating RPM naman is mid, then low. Mid ng RPM, so that's 45. Okay. Mid, low. So we have same lang, no? 4. So where is our 4? So 1:3. Okay. Low RPM. Then maximum loop. So that's how many? Okay. 1, 2, 3, 4, 5. So that's 5. So 3, 1, 6, 1, 1. Okay, never thought of 1, 1. So 1, 1. Much. So this is also 1. 1. Ating 3 is a 2. Okay, wala pa tayong 3 is a 2. So maximum 3. Maximum is 80. Okay. 3 is a 2. Okay, tama ba? Yeah, 3 is a 2. 3, 2. Okay. Here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12. 2 is to 1. We have 4. 1 is to 1 is we have, well, we don't have it yet, do we? Yeah, we don't have 1 is to 1 yet. So 1 is to 1. 20 is to 1. That's also 1. 1 is to 2. 4. 2 is to 1. We have 4. 3 is to 1. We have 6. 2 is to 2. No, 2 is to 2 natin. 2 is to 2 is 7. Tama ba? Try ito ulit. So 2 is to 2. 45 is to 2. Okay. 1, 2, 3, 4, 5, 6, 7. So 7 is 2 is to 2 is 7. 2 is to 3. Okay. Kapan 2 is to 3? Wala pa. Okay. Kita nyo, diba? Ganun ka tedious. So 2 is to 3. Wala pa tayong 2 is to 3. So 2 is to 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. We have 1 is to 3, 9, 10, 12. We have 2 is to 2. We have that 7. 3 is to 3. We got that maximum, right? Or 3 is to 3 is... Sorry. 3 is to 3 is 17. Okay. 1 is to 1 is 1. Or 1 is to 3. Okay. 1 is to 3 is 5. 3 is to 2 is 12. 2 is to 3 is 10. 2 is to 3 is 10. 1 is to 3. 1 to 3. Okay, 5. That's 5. Okay, so that's the last one. So we have, again, so we have 27. As you can see, we have 27 points. Okay, so how do we do an analysis? Okay, so we go back to start, we do DOE without factorial, and then we analyze the factorial design. So the response is the voltage. So terms, options, stepwise. So okay, so click on that, double click on that. So we have results, chapters, graphs, residual, standardized. Okay, so before in one. Okay, Pareto. No, only model terms. So results. So yeah, okay. Options, covariates, no options. So our confidence level is default. Okay, so mga tatanong, we use a default 95% confidence interval, or 95 confidence interval, and this is two-sided. So the reason for this that we have two-sided is because we are assuming that it could be yes or it could be no. Okay, so we have two-sided. So we're not saying that it is yes only, and we're not saying that it is no only. So our initial our null hypothesis here is that it is equal. Okay, so it can either be yes or a no. So okay, so okay, right. So this is the result. All right. So interpret natin. So we have RPM, we have three levels for RPM, and we have three levels for loop. And all of them have 1, 2, and 3 values, which means it's low, medium, and high. Right? So this is the analysis of variance or ANOVA. So sa analysis of variance, isa lang ang kailangan natin tingnan, no? Yung p-value, f-value. Pero dito, asterisk siya. What? Naka p-value asterisk, why? You have to ask this one. P and F value in ANOVA asterisk. Minitab. Meaning. Okay, so why? Why daw? Why? Asterisk represent missing values that cannot be calculated because the model is saturated and there are not enough degrees of freedom or error. So there is no degrees of freedom for error. So okay. So consider an example saturated as in design you choose to fit saturated model by including all effects. Missing values in a table because it is impossible for Minitab to calculate these statistics. It's impossible to calculate them because there are 0 degrees of freedom for residual error. It means that there is no residual. So okay. So previous one. 0 degrees of freedom for error cause calculations to fail as follows. Each value in adjustment is calculated by degrees of freedom. So degrees of freedom 0. When degrees of freedom is 0. Statistics non-central tendency for to 0 can reduce interesting participant example. Equilibrium. So no condition need to be specified. The system is therefore 0 variant or invariant or has no degree of freedom. So it means it's perfect. So it's a very predictable outcome. So okay. So this is not really surprising. Wanna know why? So the reason this is not really surprising is because our replicates has the same value. So ibig sabihin, when we say that the RPM is 1 and the loop is 2, even if we have multiple tries of replications, we will get the same value, which is 4. So that's the reason why there is no F1P value here, because there is no degrees of freedom. Remember the residual, okay? So remember the residual. So we have residual because we are actually making an interpolation or a regression analysis. So naalala niyo yung meron tayong equation na nakukuha in a line. So that's regression. So that's the regression. And also, kung naalala niyo sa quiz, ay sa isa sa mga items or questions sa quiz is that pinahanap kayo kung ano yung number of sales for that particular year, which is 2002. So you made an assumption or you made an estimate or prediction using an equation. So here, it's like our residual is 0. So ibig sabihin, our predicted minus the actual is 0. So ibig sabihin, there is no change. Therefore, you just perfectly predicted exactly 100% that it's going to happen. So it means that you have a perfect model. See? Model summary 100%. So that's the reason why. So that's the reason why we have 0 or we have asterisk p value and f value. Because our model summary is perfect. So it means that everything about our experiment is already been predicted as it is. Okay. So, ito yung regression equation. So, this is the regression equation for this one. Sir, medyo complicated po, no? Yes, complicated kasi, unlike before that you're only ought to find the x and y, dito, marami na factor. Okay? So, meron tayong RPM, meron tayong loop, meron tayong voltage. So, dalawa. So, as you can see, checking natin yung ating mga um, graphs. Okay? As you can see, perfectly aligned. Okay? So, it means perfectly aligned. Oh, perfect na perfect. So, yeah, 100%. No, walang duda. It's perfect. So, that's the reason why we don't have it. So, we have 0. P and F value. Okay? So, let's see about an experiment of mine in my masters. Alright. So, ito yung nagamit ko dati nung nag-thesis din ako. So, I made an experiment and I used DOE. So, pansin nyo, meron tayong p-value and f-value because my experiment it's very far from being perfect. Close ko lang ito. But the point is, I did the same experiment, but ano lang ako, high or no. So, ibig sabihin, I only used two levels, two factors. So, I used two factor, two levels DOE. So, hindi na ako low, mid, high, kundi nag-high and low ako on yes or no. Yun lang. Okay, so as you can see here, the results of analysis of variance. Okay, pansin nyo naman, so I only have two factors. I have filler and then heat treatment. So, for the filler, I have 3 levels. And for the heat treatment, I have 2. Sir, posible ba yun? Yes po. Yes. So, ano nangyayari doon? So, if you have, kasi we have 3, for example, ang factor mo A has 3 levels. So, we have low, mid, and high. Okay? And your factor B is only a yes or a no. So, yes or no. So, ganun din yun. So, basically, you have low to yes, and then low to no, and you have mid to yes, we have mid to no, and you have high to yes, you have high to no. So, basically, that's 2 times, okay? So, 2 times, so you have 12. So, 12 replicate. So, you have data, and since replication is 3, you expect that it's gonna be 3 times 3, okay? So, 3 and 3 and 6 times 4, so that's 24. Okay, so that's 24 all in all. Okay, check natin kung talagang 24. 18 lang. 18 lang. Balik natin. So if you have low, mid, and then high, and we have yes, and we have no. So triplicates 3, 6, 9, 12, 15, 18. Sorry, 18 lang talaga. So 18, we have 18 data sets. Now, we're going to interpret this one. We're going to interpret the results of the analysis of variance. So, the filler content and then heat treatment. So, what I did in this experiment is this. So, I created a new material. Alright? So, this is my new material. And this material is a combination of a filler and a polymer. Okay? So, when I combine these two, I get a new material. But what I did is I used this one as factor A and this one is factor B. And I did 3 levels for the factor, which is low, mid, and high. And the polymer, so lahat yan, constant yan. So, constant yan. So, hindi ko ginamit sa experiment yan. So, what I did is, I based it based on the concentration. So, it's gonna be the ratio of the filler is to the polymer. So, yun ang ginawa ko sa study ko. So, I used filler and polymer. So, gonna be a ratio. So, this is a ratio. So, sa study ko, I made 3 ratio. I have a low ratio, I have a mid ratio, we have a high ratio. So, yun. So what about the heat treatment? So ang heat treatment ko is only 2 levels. So it means I only used may heat, yes, and no. So ako na nag-set kung ano yung value ng heat for yes and no. And obvious naman, kapag no, walang init. And then yes, merong init. Yun lang naman. So the result of the experiment or the result of the analysis of variance here in my study is that, okay, so filler content, interpret natin ha. Huwag niyo papansinin yung DF, adjusted SS. Ito, huwag niyo papansinin yan. Ang titingnan niyo lang itong F value and yung P value. Yan lang ang titingnan niyo lagi. Okay? Pero mas importante yung P value. Because the p-value will give you an indication. Okay? So, whenever that we use a confidence interval, napakita ko sa inyo kanina, confidence interval, that is 95% or 95 by default. So, it means ang 5% is remain na unknown or uncertain. Because you cannot be sure 100% about your prediction. Because prediction is not 100% accurate or true. So, you give it 5% na 5% hindi mo alam. Yun ang ibig sabihin yan. But 95% you are sure. Okay? So, 5%. 5% divided by 2. So, that's 2.5. So, that's 2.5 each. So, you have 2.5% that it is a yes, and another 2.5% that it is no. So, yun yung mga gray areas or yun yung mga bagay na hindi mo alam. Okay? So, what about p-value? For the p-value, by default, is that if the p-value of your study is less than or equal to 0.05, you can say that you are rejecting your null hypothesis. Now, yung null hypothesis or null hypothesis in every statistical analysis is yung may pagka-negative. So, ibig sabihin, pagka-skeptic. Okay? So, ang null hypothesis automatically sa study ko is walang effect yung combined filler plus heat. So, ang null hypothesis ko is walang effect yung dalawa. So, walang magandang maidudulot. Okay? So, ibig sabihin, whenever that may p-value sa study ko is less than or equal to 0.05, I will reject the null hypothesis, which is walang epekto ang filler and heat combined. Okay, so going back to the analysis here, the p-value is of the filler content is 0.00. So, ibig sabihin, less than 0.05. So, ibig sabihin, I will reject the null hypothesis, which means that the filler, yung null hypothesis is the filler has no effect. Pero since I have a less than 0.05 p-value, I will reject the null hypothesis that says there is no effect. So, ibig sabihin, in this case, the filler content has an effect. Okay? Sa heat treatment naman, the p-value is 0.015. And 0.015 is still less than 0.05. So it means I also reject the null hypothesis about heat treatment, which says there is no effect. So since I reject it, means it is true. There is an effect, heat treatment. Okay? What about this one? Two-way interactions. So when we say that we combine filler content and heat treatment, our p-value is greater than 0.05. So it means to say that when we combine filler and heat treatment, there is really no effect. There is really no effect. So we let the null hypothesis that there is no effect. Okay, what about the model summary here? So as you can see, the R squared is 86.81%. And what does this mean? So it means that 86.81% of our experiment has been explained. Sir, medyo magulo po. Okay. Diba, we have 100% guarantee or 100% certainty. Again, since we don't know 100% all the time, it is safe to assume that our predictions are best at 95%. But in this case, I predicted the outcomes 86.81% test. So, sir, ibig po ba sabihin hindi ka pa 90, meron ka pang hindi na-predict sa study mo? Yes. Ibig sabihin, yung kulang ko sa 95% or dun sa 100%, yun yung mga bagay na hindi naisama sa study ko. Okay? Yun ang ibig sabihin nun. So, ibig sabihin, probably, aside from the filler and then the heat, I should also add another one, which is I don't know, that will further increase my model. So, ibig sabihin, mas may explain kapag nagdagdag ako ng isa pang factor. So, ibig sabihin, 2 factor is not enough. Pero, given the fact na 86.81%, it is already okay. But, we can increase the accuracy of our model if we're going to add another factor. If we're going to add a third factor. But, it doesn't really have a guarantee na tataas. Kasi, baka bumaba din lalo yung model summary. Kapag bumaba ang model summary, kapag nagdagdag tayo ng pangatlong factor, it means na hindi talaga ito dapat yung idinagdag natin. So, you know, anong ini-imply? Anong ini-imply nito? Ini-imply nito is, using this kind of analysis, we can say na we can know or we can test if something is beneficial or not beneficial in improving a certain material or a certain product. For example, if we want to test our product, for example, yung isang upuan is based on our design is already 86.81% best, and we try to add another one factor. Let's say 2 factor tayo kanina, and then we try to add another factor, and then yung ating model summary biglang bumaba sa 86%. So, ibig sabihin, yung factor na dinagdag natin is hindi siya nakapabuti. So, yun ang ibig sabihin nun. Right? So, punta natin yung ano nito, graph. Ano ba yung mga graph nito? Yan. Ito yung mga graph. Close this one. No. Okay. So, we go this one. Pansin nyo, di ba? No, normal probability plot. So, it means that it is a perfect line. We can interpret it. Okay. So, this is another plot, which is your fitted means or main effects plot. It means that there is no effect. Going back here, it says here that filler content and the combination of filler and the heat treatment will not give us. This not. Ibig sabihin, the combination of two doesn't really have an effect. Okay? Pero sir, di ba sabi mo, filler content has an effect and the heat treatment has an effect? Well, yes. But what this is trying to tell us is that pointless or hindi mo na dapat i-combine ang filler at saka heat kasi wala naman silang effect dun sa gusto mong mangyari. Okay? Pero individually speaking, may effect silang dalawa. May effect sila individually. Pero kapag pinag-combine mo, hindi. Yun ang ibig sabihin nun. So, that's how to interpret using the p-value and how to interpret it using the ANOVA. But here, if you're going to do it in a graphical matter or in a graphical manner, so ito yung ibig sabihin. So, our conductance, or ibig sabihin nito is the higher the better, okay? Mas mataas, mas maganda, mas mababa, pangit. So here, the low concentration of the filler gives us a low conductance. So, hindi to okay. Ang mid, so sir, wait lang, ano po yung dash line? So, yan yung average, okay? So, yung average. So, ang mid is nasa lagpas 180 at yung high is lagpas. So, ibig sabihin, our increasing filler content or concentration gives us a high conductance. Ang tanong, lumalabas ba yan sa ANOVA? Filler content? Yes. So, pansin nyo naman, 0.000. So, it means that there is an effect. Sa heat treatment naman, is there an effect? So, looking at no, mataas ang conductance kaysa sa yes. So, it means that it does it does affect our conductance kasi bumababa. But if we're going to combine the filler content and the treatment, it doesn't really hindi talaga siya importante. Okay? So, if you're going to do the math, for example, if the filler content is 1, pero yung hit mo naman ay 0, well, syempre magre-yield dun sa 0. So, even if mag 100,000 man yan, times 0 is still 0. So, yun ang ibig sabihin nito. If we're going to combine the two, there is really no effect. Okay? So, I hope that's clear. So, that's the point of the design of experiments. I don't really expect na magigets nyo in isa-isang pasadahan. But I'm sure that if you're going to do your experiment yourself, you're going to understand, mag-make sense itong mga pinagsasabi ko sa inyo. Okay? So, there will be a final exam that will be posted on, please, sana mga Friday makapag-post ako until, so again, Friday until Sunday. So, sana makabalik na yung internet ng smart. And I wish you all the best. Bye-bye.